I generate traffic. My routing, whatever my routing is, my default gateway, my routing on my router, sends the traffic out to the internet. Okay? At some point, you're going to get to a device that has a public address, or at least has public addresses routed to it. That's usually, like I said, your edge device, maybe a firewall or a router on the edge of your network. Within that router, you have a policy, what we call a NAT policy. That NAT policy defines who gets natted, how they get natted, and then the router itself maintains a database of those translations called a NAT table. So that when the traffic returns to that router, the router can reference that table and say, oh, okay, this traffic matches this entry in the table, so I'm going to untranslate or reverse the translation process and send it back to the inside host. In general, that's how NAT works.
Can that be done dynamically, or does that have to be done statically?
What do you mean?
Do you have to manually add that table to the router?
The table is created automatically based on your policy. That NAT table is created automatically based on your NAT policies. All right. Now, some entries in the table are permanent, if you're doing static NAT translation, for example. But in most cases, the table is built dynamically as traffic flows through the device. All right. Inside global, again, the public address that represents my inside host. Inside local, the private address that represents my inside host. Outside local and outside global, the public address that represents my destination. Notice that those addresses are the same. Again, they're almost always going to be the same because you just generally never know what the private address is of your destination because it's hidden. All right? So there are three types of NAT that we're going to talk about. We've got static NAT, dynamic NAT, and port address translation, what we call overload NAT. Let's talk about static NAT first. Static NAT is a one-to-one mapping of local and global addresses. Now you know what local and global means, right? You see the word local, you think private. You see the word global, you think public, period. If there's anything you get from this chapter, that should be it. Local is private, global is public. Okay? Static NAT uses a one-to-one mapping of local private addresses to public addresses. Okay? These mappings are configured by the network administrator because they're static. It's like doing something called a static route. Static NAT is a particularly useful when you have servers inside your network that have to be accessible from the outside. And this is really the most common reason why you would implement static NAT. You might have a web server that you want customers to be able to access. You might have an FTP server that you want customers to be able to access from the outside. So you're going to set up a static NAT profile and publish the global address to those customers so that they can access those servers. All right? Now, the last bullet point that you see there is really just an example, right? SSH to a server is just one example of why you would want static NAT. Well, let's take a look at that, all right? I've got a router on the edge of my network. That router has a local presence inside my network, and it has a global presence on the internet, okay? The router has a local presence on the inside of my network and a global presence on the internet. So that's my NAT boundary. I've got a server inside my network that has an inside local address of 192.168.10.10. But I want an administrator on the internet to be able to SSH to that server. Now, that person on the internet can't SSH to the local address because those local addresses are not routable on the internet. So I have to set up some sort of network address translation profile that allows that person on the internet to SSH to 209.165.200.226. That network address is being routed by my ISP to my router. And then the router has a policy that translates that 226 address to 10.10. Does that make sense? All right. Of course, we're going to see how that's configured here in a minute.
That's actually the only kind of NAT I've ever used.
Oh, that can't be true at all.
Well,
Right.
I mean, that I've had to
Configure?
configure.
Yeah. Because I say the most common form of that is what we're using today, which is everybody on the inside gets translated to one address on the outside.
That was because a database was not allowed to be on someone's network, but they had to get the data.
Right.
So we had to
Set up a static NAT translation.
request, you know.
Yep. And that's really what the most common form of static NAT is. Static NAT does not solve the problem that NAT originally tried to solve, does it? What did NAT try to solve originally? The lack of addresses, right? Well, static NAT is one-to-one, so it doesn't resolve that at all. All right, now how do I configure that? We'll see that a little bit later on. The second form of NAT is something called dynamic NAT. Now, if you see the word dynamic in relation to NAT, think of an address pool. When you see the word dynamic NAT in relation to NAT, think of an address pool. Now, this is the least common form of NAT that you're going to see by itself. Because essentially what you have is you have a pool of addresses, a pool of public addresses, and whenever somebody wants to go out to the internet, they simply grab an address from that pool. And they go out to the internet, and they come back, whatever, okay? So let's say that I have 500 hosts inside my network, but for some reason only 10 of those hosts need to go out to the internet at the same time. I would create a pool of addresses of 10 public addresses, and then whenever somebody wanted to go out to the internet, they would just borrow an address from the pool. When they're done going to the internet, they would release the address back into the pool. Now you can see why that would probably be the least common form of NAT, right? Because who doesn't go to the internet now? Everybody goes to the internet all the time. All right? So dynamic NAT is a pool of addresses. All right, we'll see that configuration a little bit later on as well. Now, the most common form of NAT is something called PAT, Port Address Translation, where everybody on the inside of the network gets translated to a single address on the outside. So we're mapping multiple private addresses to a single public address. Now, the reason why they call this port address translation is because the way that the router maintains a database of these users is by their port numbers. When we say ports, we're talking about TCP ports, UDP ports, protocol IDs, those kinds of things. When you think about it, everybody in this hotel is using the same address to go to the internet. It doesn't matter who you are. There might be 400 people in this hotel. They're all using the same address to go to the internet. So the router has to figure out the return traffic. What host does the return traffic go to? And it does that by monitoring all of the properties of each connection that goes out to the internet, including port numbers, because port numbers are unique. Destinations are unique as well. All right? All right, let's take a look at some configurations of these. Well, let's do this slide real quick. NAT translates IP addresses on a one-to-one basis between private and public, at least static NAT does. PAT modifies the address and port number. NAT forwards an incoming packet to their destination by referring to the incoming source IP given by the host on the public network, whereas PAT is generally only one for every few publicly exposed IP addresses. What they mean is there's generally only one address for every host on the inside. That's what they're referring to there. All right. When we see the configuration, it will make a little bit more sense as we start to go through the configuration of each of these. All right, there are two basic tasks when you're configuring static NAT. Now, I want to preface this whole discussion by saying this is specific to Cisco, number one, obviously. And number two, this is specific to a router when we're doing NAT on a router. This is not the same way NAT is done on a firewall. Firewalls use different ways of doing NAT translations. The concepts are the same. The syntax and the configuration is slightly different. Okay? So it's really simple on a router. Here's how it works. The first thing you have to do, and this applies to any form of NAT. And by the way, this is related directly to what you're going to see on the lab exercise on the test. Okay? There's a NAT question on the lab exercise on the test. So this chapter is intended to get you prepared for that question, which you guys will be looking at lunchtime. The first thing that you would generally do, at least this is the first thing that I would do, is I would specify my NAT policy. Notice that that's done in global configuration mode. Global configuration mode. I'm going to say, I'm going to create a policy, and we do that by saying IP NAT. I'm going to IP NAT traffic coming from the inside. The source of that address traffic is 192.168.10.254, so that's the local address, and that traffic is going to get translated to 209.165.201.5. That's it. That is my static NAT policy. I'm saying, okay, if the host address is if the host address is 192.168.10.254, I want to translate that to 209.165.201.5. And by the way, those static NAT translations are bidirectional. So it will allow traffic to come in that's initiated from the outside. It'll allow traffic to go out that's initiated from the inside. This is the only form of NAT that's bidirectional. The other forms of NAT require the connections to be established from the inside first. Now, it's very important that you do the second step. And the second step says, I'm going to tell the router which interfaces are running NAT. And we do that by specifying IP NAT inside and IP NAT outside. Gig 00 is the inside interface. Serial 010 is the outside interface. Until you do those two commands, this NAT policy doesn't do anything. Now, what happens if there's a host on the inside of the network that doesn't match a policy? Let's say that the PC on the inside network is 192.168.10.250, and it tries to go out to the internet. I have IP NAT inside on gig 00. Does that affect the host of 192.168.10.250?
Yeah, it's not going to recognize where to send it, but the global.
Well, okay, yes. There's no policy that matches that host, right? The router is just going to route the packet normally. It's not going to translate it. Just because there's no policy for a particular type of traffic does not mean that that traffic now gets dropped. The router's going to route the traffic untranslated. Now, granted, when it goes out to the internet, it's going to get dropped because the ISPs are not going to allow traffic from a private address. But from a routing perspective, the router doesn't drop it because there's no translation. It just routes it without translating. And in this case, it would get routed because the router probably just has a default route to the internet, right? So it would route it. Because remember, routers don't route based on source. Routers route based on destination. So it doesn't care what the source is. I just want to make it clear that just because a packet doesn't match a NAT policy doesn't mean because I have NAT applied, the packet gets dropped. It's not the case. This is not a security mechanism. If a packet doesn't match a NAT policy, it just simply doesn't get NATed and it gets routed anyway. Does that make sense? How do I verify my NAT policy? Show Ip Nat Translations, and I can see my inside global and my inside local. Now you know what global means. Global means public, local means private. So how does it work? Well, it works in both directions, but they've given us an example. We have a client on the internet that goes to 201.5. That 201.5 packet gets routed to my router by my ISP. The router has, on the outside interface, the router has this configuration, right? Ip Nat outside. So it says, oh, I have Ip Nat outside on that interface. I better go check my NAT table to see if this packet gets translated. The packet happens to match a translation entry, so it reverses the translation, sends the packet in as a private address. The private host responds to the client on the internet. I have Ip Nat inside on that interface, so what does the router do? It says I'm going to go ahead and apply my NAT policy because I have Ip Nat inside, right? You guys follow me? All right.
What is the SA and DA?
Source address, destination address. One thing I want to fix on this one, though. I'm a little bit anal when it comes to stuff like this. The interface here is not serial. So SADA is source address, destination address. Okay. Got it? I mean, it's nothing crazy about this. All it's saying is, hey, this is what the NAT is going to look like. All right? Oops. Oh, it crashed. Dang. Good old Microsoft. Okay. You guys follow me? All right. So actually the configuration is pretty straightforward. Literally only 3 commands. And if I want to create additional policies for other hosts, I just add another Ip Nat inside command. So if I have 4 or 5 or 6 or 7 hosts on the inside of my network that I want to do static translation for, I would have 4 or 5 or 6 or 7 IP NAT statements. All right? You have to have the IP NAT inside and the IP NAT outside. How do I verify? Well, I can do show IP NAT translations, or I can do clear or show IP NAT statistics. Show IP NAT statistics says, oh, I've got one static translation. The outside interface is serial 010. The inside interface is gig 00. I haven't generated any traffic, so I don't have any hits against that policy. But as soon as I start generating traffic, I can see hits against that particular policy. And that's just simply show IP NAT statistics. It's a very simple command. Okay? A miss would be where traffic is passing through the interfaces that didn't get translated. All right? Dynamic NAT. As we mentioned before, if we're going to use dynamic NAT, we're talking about a pool of addresses. A pool of addresses. So obviously with the configuration of dynamic NAT, we're going to be required to configure a pool. Again, the least common form of NAT that you're going to see is a pool. All right, here's the configuration. Again, same topology. I've got a router that's participating on the inside of the network. I've got a router that's participating on the internet. That router is my NAT boundary. The first task is to create your pool of addresses. We use the command IP NAT pool. And in this case, the pool has a name. The name of our pool is called NAT pool. The starting address of that pool is 225. The ending address of that pool is 254. And the subnet mask for the addresses in the pool is 224. Got it? Now we haven't done access lists yet. We will be talking about access lists. We haven't done that yet. Okay? But an access list allows me to match a specific set of criteria for a packet. In this particular case, the access list is matching any address that starts with 192.168.10. Don't worry about the syntax of the ACL just yet. We're going to talk about access lists in a whole nother chapter. But just trust me when I say we're matching any address that starts with 192.168.10. Which would be what?
Private.
My private network, right? Everybody on the inside of my network. And then I have my NAT policy. The NAT policy says I'm going to NAT traffic that matches access list 10. That's where source list 10 comes in. I'm going to match all traffic that matches access list 10. Let me draw it on here. Source list 10. That 10 is referring to this access list 10. Okay? And I'm going to translate those addresses to the pool, NAT pool. And then I just turn on NAT on the inside and outside interface. Now there's a huge limitation to this type of NAT, isn't there? Because how many people can go out to the internet? 10. However many people, however many addresses there are in the pool. Not 10. 10 doesn't have anything to do with the number of hosts. 10 is the access list number. How many people can go out to the internet? Whatever 225 to 254 is. Isn't that the range of addresses in the pool? The 10 has nothing to do with the number of hosts.
Oh, that's the name of it.
That's the access list number. Which is why they say source list 10. List means access list. So 225, 226, 227, 228, 229, 230, and there's quite a few. Looks like 31 addresses. So up to 31 people can go out to the internet. 30, sorry, because 224 is not included. 30 people can go to the internet. All right? Now we know that this is not very practical because who doesn't go to the internet? I mean, so many things use the internet. So, not very practical. Same table, analyzing the dynamic NAT. We don't have to get into that. Same thing here. They're just talking about how the addresses get translated, where they get translated from. So again, to verify, show Ip Nat Translations. We can see that, for example, host 10.10 used the 226 address, host 11.10 used the 227 address, and so on. If we use the verbose option, we can even see how long that address has been used, what time the translation occurred. So the first address, 226, has been in use for 1 minute and 54 seconds. The second address has been in use for 1 minute and 51 seconds. And there is a timeout period as well. So that if traffic isn't being generated after a certain period of time, the address is automatically released back into the pool. Okay? Same thing, show Ip Nat statistics. In this particular case, I see that I have 2 dynamic entries, which means I have 2 active sessions using NAT pool 1. In this case, the name of the pool doesn't match. I'd have to fix that. That would take a little bit longer to fix. I like things to kind of match. Oh well. All right. Now, let's talk about where this might apply more appropriately. It's something called overloading. This is a combination of 2 forms of NAT. It is a combination of dynamic NAT with the last form of NAT, which is what we call overload, or port address translation. I create the pool. As you can see, the pool is pretty much the same. All right. I have an access list that matches my inside network. And I have a policy. Now notice the difference of the policy this time. I'm saying Ip Nat my traffic based on access list 1. And I'm going to NAT the clients to an address in the pool, NAT pool, but there's only one single difference here. And that difference is what?
It says overload.
Overload, exactly. That is the key to this entire configuration. Because with overload, what are we saying? We're saying, okay, I want to use the 226 address more than once. In fact, I want to use the 226 address over and over and over and over again until I've run out of port numbers. So annoying. All right, you already cut that part. It's not going to get any shorter.
Where is it? Does overload, you just take it for granted that it uses the first?
Yes, that's what it means. When you use the keyword overload, it's basically saying use the address more than once, up to its maximum, right? Now there is a maximum because when we're talking about port address translation, we're talking about TCP and UDP port numbers. Well, TCP and UDP port numbers are only 16 bits in length. So mathematically, there are only 65,536 port numbers. Now, this would be a configuration that would be used in a very, very large enterprise, maybe 10,000, 20,000, 30,000 users going out to the internet through the same connection. Because what's going to happen is each address in the pool is going to be used over and over and over again until it's exhausted.